So in this video, we are going to look at finding the instantaneous rate of change. We looked previously at the rate of change, the average rate of change, which is the rate of change over an interval. The instantaneous rate of change is not over an interval, it's at a specific X value, often a specific instant of time or a specific unit if we're looking at like a revenue example. And so the derivative f prime of a measures the instantaneous rate of change of f of x at x equals a. So again, it's the rate of change at a certain instant of time. And graphically, it's the slope of the tangent line. So if I have my curve, I want to find the rate of change at this specific time when x is equal to a. And algebraically, we find it by doing the derivative. And for now, to find the derivative, we use that difference quotient, where it's the limit as h approaches 0 of f of x plus h minus f of x over h. And then once we find this function, we will plug in whatever x value they give. So then we would plug in x equals a to our derivative once we calculate it. So for an example, we are going to find the instantaneous rate of change of f of x squared plus 2x at x equals 3. So again, we're going to use that definition, the limit as h approaches 0 of f of x plus h minus f of x over h. So whether you do this all at one time or you do it on the side, you can find f of x plus h and simplify it a little bit if you want to make it easier. So we do x plus h squared plus 2 times x plus h. So everywhere we see an x, we replace it with this quantity x plus h. So remember, when you're squaring something, you're multiplying it by itself. Okay, and then we can distribute this too. So this gives me x squared plus xh plus xh plus h squared. And then I have plus 2x plus 2h. And that gives me x squared plus 2xh plus h squared plus 2x plus 2h. And there's no like terms to combine, so that's what f of x plus h equals. F of x is just the original function. So if I come down here to find the derivative, we take the limit as h approaches 0 of this f of x plus h, which is what we just found. Okay, we're going to subtract f of x, which if we come back is x squared plus 2x. Okay, remember, we're subtracting this entire quantity, so be careful with that. And then over h. So remember, when we're subtracting, we need to distribute the negative, or make sure that if you don't want to write it with the parentheses, that you're changing the signs on both of them. Okay, so I distributed the negative. And what should always happen is any term that doesn't have an h in it should cancel. If not, something went wrong. So the x squareds add to 0 and they cancel. And then the 2x adds to 0 and they cancel. So if that doesn't happen, you made a mistake. So then we have 2xh plus h squared minus 2h over h. And then when we take this limit as h approaches 0, we can divide each term by that h. Okay, and remember, each time I'm doing this, I have to write the limit until I actually take the limit, which is when I can plug in 0 for h, which I can't do anytime that the h is in the denominator, because that gives me 0 in the denominator. So here the h's cancel, so I get 2x plus, here I get h to the first, and here I just get 2. So then now I can plug in my 0 for h. So I get 2x plus 0 minus 2. And remember, this is equal to f prime of x. So we're finding that f prime of x is equal to 2x minus 2. So that's my derivative. We want to find this at x equals 3. So once I have my derivative, I can plug in 3. And that will give me the instantaneous rate of change at x equals 3. So 2 times 3 is 6. 6 minus 2 is 4. So we found that the instantaneous rate of change at x equals 4 of f of x is 4. Or sorry, at x equals 3 of f of x is 4. Okay, and again, it's like the slope of the tangent line at x equals 3 is 4.